And welcome back to another little dev blog thing. Oh, accidentally opened up the help menu. So what I've been working on is Frustum culling for the Voxel engine. Frustum culling, if you're not aware of the concept, is the idea that you're only rendering things which are visible on screen. So it's called Frustum culling because the view area of which a player or a human being or anything, well, not anything I suppose, because some animals have eyes on the side of their head, but for the most part, human beings see things in front of them in the shape of a cone or a pyramid shape, with the point being your eye. And I should let's draw a diagram in Paint. Let's do that. Here we go. We'll draw a diagram. Okay. So Frustum culling is the idea that you are a little person here. This is you. Boop. And everything you see in the world, that's not the right triangle. Do we have a good triangle? Okay, fine, I'll draw a triangle. Everything you see in the world goes inside of a thingy-mabob. I have to select my pin again, don't I? Okay. Goes inside of a cone. So this is your whole view area. Of course, this would stretch off much, much further, like maybe like up to a mile. And if you have objects, say cubes, outside of the frustum, you don't want them to be showed up. Well, this one would probably be. However, if you have ones entirely inside of it, or partially inside of it, you want those to be rendered. So the whole idea is you have all these cubes behind you that don't really need to be processed by the GPU, and you don't want them to be loaded by the game, otherwise it's just a waste of FPS. And it really does impact performance. Every single game you've ever played, I guess that's not every single 3D game you've ever played, most likely took advantage of some form of culling. It might have been Frustum culling, it might have been like occlusion, or it might have used a combination. But for my case, I'm going to use Frustum culling. So this is obviously going to be in 3D space. So we have that set up. Oh, this is OBS, not. We have that set up right now in our world. And I've also added an FPS counter. I made the text and a visible models meter, so it'll tell you how many models is on screen. So as you can see, we have visible models 2000. When we come over here and only look at this corner, we got visible models 57. And you can also see this working by the bottom of the screen. You see, as I move up, the cubes disappear. So obviously that's not supposed to happen. It's very good that it's telling me it's working, but the problem is we don't want the cubes. We want cubes that are even partially on screen to be rendered. This is a huge problem with a lot of, with setting this up, is that it's treating as it's looking for the center of the cube, right? So if you watch the bottom of my screen, as soon as I move it over the center, it disappears. So in my code, let's close this. I have a little area where I had to do some stuff with bounding boxes to set to and I had to redefine the model instance, which are my little boxes. I had to redefine it as a game object in order to tell the program that I want you to render it even if it's even partially on screen. If any of this is on screen, render it. So this works a lot better. In fact, it works perfectly. So there we go. So now we have all the cubes that are behind me are being not rendered, but it's completely seamless. Yeah, now there's still a lot of problems with this, right? So I'm getting 57 FPS, 48, which is pretty good, but when you think about the fact that there's only just a few thousand cubes here, no physics, no mobs, no nothing. There's nothing else to process other than them being on the screen itself. And if I go up and just put them all in view, I drop down to 30 frames. So why is this happening? Why is this having such bad performance? So there's several different reasons. One could be the fact that there's individual models that need to be processed. And one possible solution to that is there's a way you can actually tell the program to combine all these models into a single model and load it, and then break them apart whenever you're interacting with it. And then another problem that is probably the biggest cause is if I get myself inside of a cube here, you can see something very interesting. There's no way to slow down this. All right, you can see that all 5 sides, the top and the bottom are being rendered, but they're not being shown. All 5 sides of this cube is being rendered. So The one we're inside of isn't rendering, but the other ones outside of it are. So all 5 sides are, oh, 6 sides, there's 6 sides on a cube, are being rendered, even though at any given time we may only be able to see a maximum of 3. So that's a problem, because that means it's essentially taking up 5 times as much resource, 6 times as much resources as it needs to, up to 6. Because if we're above it, we only need to load 1 face. But where'd it go? Oh shit, there it is. So our problem here is we need to write part of our program that'll be able to tell which sides of the cubes are visible, and then pass it into our render methods in order to just render one side or whatever sides are visible. And I think that'll improve FPS a lot, but I'll also look into the idea of being able to combine all the models into a single model instance. I think that'd be great because ultimately I want these cubes to make up very small parts of the environment instead of big ones. So I mean, like, such as in Minecraft, it probably isn't a big deal that, I'm trying to get lined up. Probably isn't a big deal that cubes about this big, or maybe larger, and that they're individual models. But when I want 9 times as many cubes in the space, I'm gonna need a little bit more processing, or not processing, a little more optimization. Alrighty, I think that's gonna do it for this little dev blog thing, and